Good day, sir. I am Franz Erick Sabugo from BSN19KT Eriksson, and in this video, I will dissect a pig's kidney and locate its major structures and also trace the path of the blood and the urine.
Now, let us examine the external anatomy of a pig's kidney. This kidney is roughly 5 inches long, 2 inches wide, and half inch thick.
It is roughly the size of the large fish, and kidneys are bean-shaped organs that come in pairs.
A kidney is a reddish-brown bean-shaped organ with both convex and concave borders.
For the superficial parts, the kidney is composed of three protective layers, namely
The renal fascia, adipose capsule, and the renal capsule. The renal fascia is a layer of connective tissue encapsulating the kidneys and the adrenal gland. The adipose capsule is sometimes included in the structure of the renal capsule. It provides some protection from trauma and damage. And the renal capsule is the one that covers the outer surface of each kidney. Now, let us locate the renal artery that is located near the renal vein. The renal artery is where the blood enters the kidney. Now let us find the renal vein where blood exits the kidney. You can differentiate them by its wall thickness because the renal artery has thicker wall than the renal vein. Now, let us cut the kidney in half so that we can locate the internal parts of it. Now, let us locate the three main regions of the kidney. In this frontal section of the kidney, there are three main regions that can be seen. First, we have the renal cortex, which is this outer region of the kidney. It is a space for blood vessels that connect the nephrons, which are the functional and structural unit of the kidney, that begins in the cortex and mostly located in the renal medulla. The nephron is composed of renal corpuscle, which is responsible in the filtration of plasma. This is where the glomerulus and the Bowman's capsule is located. This darker region is the renal medulla. It is the innermost part of the kidney, and its function is to regulate the concentration of the urine. You can also notice the pyramid-like tissues in the renal medulla, and these are called the renal pyramids. These pyramids are made of collecting ducts that transport urine from the kidney tubules of the nephrons in the renal cortex to the cup-shaped cavities of the calyxes, where it is collected before passing through the ureter and bladder. The renal columns contains middle-sized arteries and veins which carry blood between the nephrons and the renal artery and veins. This is the renal pelvis. It is a flat funnel-shaped tube that continues with a urethra leaving the hilum. The extension of the pelvis is called the calyces. Calyces forms a cup-shaped drains that collect urine which continuously drains from the tips of the pyramids and into the pelvis when urine passes out through the ureter and to the bladder. And this is the urethra. Now, let us know the pathway of the blood through the kidney. Unfiltered blood enters the kidney through the renal arteries found in the hilum region. Then, it branches off in the segmental arteries and it will run along the spaces between the renal pyramids known as the renal columns. These blood vessels are known as the interloper arteries, after which it will split off into the top of the base of the renal pyramids known as the arcuate arteries. Then, it will further branch off into the renal cortex as interlobular arteries or cortical radiate arteries. These blood vessels serves multiple nephrons where filtration of the blood occurs specifically in the glomerulus. Blood is supplied to the glomerulus via the afferent arterioles. Once the wastes are filtered, blood exits through the afferent arterioles and it then diverges into the peritubular capillaries, which supplies blood into the proximal and distal convoluted tubules and the collecting duct. It will converge again in the cortical radiate veins or in the interlobular veins. Then it will pass through the arcuate veins at the base of the pyramid. This leads the blood back to the renal columns into the interlobal veins, which then goes to the renal veins in the hilum region, before sending the filtered blood to the inferior vena cava of the heart. In the formation of urine, there are three processes. First is the glomerular filtration, which happens in the renal cortex. The origin of filtrates comes from the water and smaller solutes forced to the capillary walls of the blood vessels and glomerular capsule. Then second, during tubular absorption, which happens the moment when the filter from the Bowman's capsule enters a proximal convoluted tubule. This happens again in the renal cortex. Useful substances in the filtrate are transported out into the tubule cells and then return to the bloodstream to the adjacent capillaries. And majority of the water absorption happens in the proximal convoluted tubule of the cortex. Lastly, during tubular secretion, hydrogen and potassium ions, creatinine and drugs are further removed from the peritubular blood, and it is executed by the tubule cells into the filtrate. These secreted ions plus the filtrate forms the urine. The urine then flows out of the neck of the front of the tubule into the collecting duct, then passing through the renal pelvis into the ureter and then down to the urinary bladder. So that concludes the pathway of the filtrate that become urine, and also that's the end of this video. Once again, I'm Franz Erick Sabugo from BSN 1 Section 9 KT Eriksson, and thank you for watching. Stay safe and God bless.